3rd of September 1944, fields west of Aachen, near the Belgian frontier. Dawn lifts in a thin gray sheet. Beet leaves sweat with dew. The hedgerows breathe wet soil and the faint bite of cordite. A German scout car sits empty, its crew scraping a jerry can for the last syrup of benzene. Behind them, the road is silent. To the west, an unbroken surf of engines refuses to fade. No tanker columns, no smoking depots. Only that hum, as if fuel were welling up from the earth itself. Flashback, earlier that summer, while Normandy burned down to embers, British and American engineers opened a front beneath the waterline. PLUTO, the pipeline under the ocean, pushed armored HAIS and HAMEL pipes across the channel, 3-inch arteries that by late summer 1944 were delivering thousands of tons of gasoline to newly won beaches and ports. From those landfalls, the work crept inland. Welded steel and hose threaded under lanes, carried across culverts, hidden in hedge bottoms, pump stations spaced like beating hearts. The overland web would stretch more than 200 miles as the pursuit advanced, a steel artery feeding the armies faster than road tankers ever could. Returned to 3rd in September. For the Wehrmacht, starving for petrol, it felt like sorcery. For Allied logisticians, it was arithmetic. Pressure, lift, gallons per minute, and the discipline to keep pumps turning through mud, sabotage, and shell fire. Engines roared because an invisible river ran beneath them, turning logistics into momentum. As the columns pressed toward the German border, a new premise of modern war emerged. Victory could hinge on plumbing as much as on armor. Next, we trace how this idea left the drawing board, who conceived it, who built it, and how they kept it hidden in plain sight. August 1943, London. Deep beneath the War Office in Whitehall, maps of Europe covered the walls like veins on a body, each red line pulsing toward an unspoken truth. The Allied war machine would live or die by gasoline. Every strategy, every landing, every armored push depended not on courage or even on numbers, but on octane. A Sherman tank could burn through 2 gallons with every mile it clawed forward. A P-47 Thunderbolt devoured nearly 200 gallons every hour it circled above France. Behind every division loomed a thirst that no depot seemed able to quench. When Operation Overlord finally erupted, planners knew it would require over 2.5 million gallons of fuel a day merely to keep the front moving, a figure so staggering that it bordered on the absurd. Yet, by the middle of 1943, the Allies faced an impasse. Oil tankers could not risk the mined, bomb-haunted waters off Normandy. Even small coastal craft could not unload fast enough for the mechanized storm that D-Day would unleash. Jerrycans might serve the infantry, but for tanks and trucks racing toward Paris, they were a drop in a desert. The British War Office called it the fuel bottleneck, a polite phrase for logistical paralysis. The Germans had suffered this same agony in Russia, watching entire panzer groups grind to a halt for lack of diesel. But the Allies possessed something the Reich no longer did: industrial imagination. In Churchill's scientific advisory circles, a question began to echo. What if oil itself could cross the channel? What if, instead of convoys, a pipeline carried the lifeblood of war under the sea? It sounded lunatic. An engineer's fantasy whispered in a city still smoldering from the Blitz. But necessity has a way of turning dreamers into pragmatists. Soon the Anglo-Iranian Oil Company, the British Admiralty, and America's Navy Seabees were summoned to merge their skills. Civil engineers, petroleum experts, and submarine cable specialists began sketching blueprints for something that had never existed. A flexible steel artery that could snake beneath the waves and feed an army from the British coast. While the generals rehearsed beach landings and the soldiers studied sand tables, another invasion, silent, mechanical, and secret, was being conceived. Before the first boot hit the sands of Normandy, the Allies were already preparing to conquer Europe with an invisible tide of fuel. November 1942, London's Combined Operations Headquarters buzzed with a strange energy. Admiral Lord Louis Mountbatten, known for his audacious experiments in amphibious warfare, had summoned Britain's top oil engineers and scientists. The question he posed seemed almost absurd. Could fuel, not men, be sent across the English Channel beneath the waves, through a pipe stretching dozens of miles without ships, without exposure and without alerting the enemy? In that dimly lit war room, where maps of the Channel shimmered with pinpricks of red and blue, the impossible began to take form. The idea, codenamed PLUTO, pipeline under the ocean, was as bold as it was perilous. To succeed, a continuous line of petrol had to travel through the world's most dangerous waters, surviving pressure at depths over 300 feet, outlasting salt corrosion, and avoiding detection by German minesweepers and patrol aircraft. Traditional engineering offered no precedent, but Britain's wartime laboratories thrived on defying precedent. Two rival designs soon emerged from the feverish competition of invention: the HAMEL pipe, a flexible steel tube reinforced with layers of lead and paper insulation, and the HAIS pipe, a daring adaptation of submarine telegraph cable technology, miles of steel and copper wire reimagined to carry not signals, but fuel. Manufacture began at Siemens Brothers and Henley's Cable Works, names once synonymous with peacetime communication, now enlisted in a war of logistics. In secret test runs off the Isle of Wight, engineers fought waves, fouled propellers, and pressure ruptures. Then, in the summer of 1943, came triumph. 30 miles of HAIS pipe successfully laid and tested, no leaks, no failures. What had begun as a fantasy on a drawing board now pulsed with potential. By spring 1944, Britain's factories were operating in silent coordination, producing over 500 miles of coiled steel arteries. Civilian ships were refitted into massive conundrums, drum-shaped vessels capable of spooling out miles of pipe as they advanced. Each reel carried the promise of mechanized movement across Europe. Even the crews handling them were kept in ignorance, told only that they were aiding in communications work. German intelligence, intercepting fragments of rumor, guessed at secret Allied cables, never suspecting the truth that soon would fuel an empire of invasion. As May 1944 neared its end, the engineers of PLUTO worked without pause. The beaches of Normandy waited, and with them, the test of whether a dream born in a London war room could feed an army across a continent. June 6, 1944, Normandy. The dawn sky glowed with fire and smoke as waves of landing craft carved through surf stained with oil. Amid the chaos of gunfire and wreckage, something unseen dictated the rhythm of battle: fuel. Every jeep, tank, and truck depended on it, and every drop reaching the beaches was fought for. In those first weeks after D-Day, Allied forces relied on a patchwork system: millions of 5-gallon jerry cans ferried by landing craft from depots in southern England. Crews worked knee-deep in seawater, forming human chains under Luftwaffe raids. Each gallon offloaded was a small miracle of endurance, but the system groaned under its own weight. The invasion had succeeded, yet the advancing armies threatened to outrun their lifeblood. Then, on August 22, 1944, the miracle changed form. At a quiet pumping station on the Isle of Wight, valves turned and gauges trembled. Engineers of the British Admiralty and American Seabees watched as fuel began to move, not in drums or cans, but through a 4-inch steel artery stretching 70 miles beneath the English Channel. The operation bore a simple code name: Bambi. Within hours, petrol was flowing into storage tanks at Cherbourg, reaching the Normandy front lines without a single ship crossing enemy waters. The line's capacity reached nearly 300,000 gallons per day, a modest start by strategic standards, but a triumph beyond measure for those who had built it. Pressure fluctuations, saltwater seepage, and the Channel's notorious currents tested every inch of the system. Yet the pumps held steady. German reconnaissance flights, seeing strange ships towing drums near the Isle of Wight, misreported them as mine-laying craft. The deception held perfectly. While Wehrmacht fuel depots in France stood empty, the Allies were feeding their columns with an invisible river of petrol. By early September, Patton's Third Army and Montgomery's armored divisions were pushing toward Paris, and the steady hum of engines proved Pluto's promise. The Germans had once believed Allied logistics would collapse on the beaches. Instead, they now faced an opponent whose supply lines flowed faster than the front could move. Bambi was only the first artery of a far greater network, one that would soon snake across Europe itself. Late August 1944, Cherbourg, newly liberated but still scarred by months of bombardment. Amid the wreckage of cranes and half-sunken freighters, a different kind of army arrived. Engineers carrying blueprints instead of rifles. Their orders were revolutionary, to push the miracle of PLUTO beyond the Channel, transforming it from a single oceanic artery into a continental network. The new operation bore a whimsical code name, Dumbo, but its ambition was anything but light-hearted. Its goal, to follow the Allied advance with a buried steel bloodstream stretching from the Normandy beaches to the German frontier. Under the command of the U.S. Army's 1st and 2nd Engineer Special Brigades, together with the British Royal Engineers, construction began before the smoke of Normandy had cleared. At Port-en-Bessin, near Bayeux, massive fuel depots were linked to underground pumping stations. From there, 3- and 4-inch welded steel pipes snaked eastward, through hedgerows, across meadows, and beneath roads bombed into gravel. Crews worked in secrecy and speed, welding by night, masking the trenches by day with soil and camouflage netting. As tanks rolled forward, Dumbo crept silently behind them, a mechanical shadow keeping pace with the liberation. By October 1944, the first lines reached the Seine River, supplying fuel to Patton's fast-moving columns. 2 months later, the network spanned the Meuse, feeding both the British 21st Army Group and the American 3rd Army as they prepared for the final drive toward Germany. The figures defied imagination. More than 1,200 miles of pipe, over 150 pumping stations, and daily flow rates exceeding 1 million gallons. What had begun as a 70-mile undersea link now pulsed across half of Europe. For the Germans, the effect was bewildering. Despite air raids that shattered bridges and burned supply depots, Allied armor never faltered for lack of fuel. Wehrmacht intelligence could not comprehend how such consumption persisted without visible convoys. The Luftwaffe began targeting road columns and fuel trucks, futile strikes against a supply system that now ran invisibly beneath their wings. By the time Allied forces reached the Rhine, Dumbo had become the quiet engine of victory, an underground miracle that transformed the landscape of warfare. The war of tanks and planes was being won, quite literally by men with shovels, welders, and pressure gauges. October 1944, headquarters of Fremde Heere West, the German Army's Western Intelligence Division, buzzed with disbelief. Field reports arriving from France painted an impossible picture. Allied armored divisions were advancing with a speed no fuel logistics could justify. Rail bridges lay in ruins, tanker convoys were minimal, yet enemy engines never seemed to stall. Analysts first suspected exaggerated claims, perhaps clever Allied deception. But as reports multiplied, so did unease. Something unseen was feeding the Allied war machine. Interrogations of captured truck drivers and engineers offered cryptic hints. Some prisoners spoke of pipes under the earth, carrying petrol straight to the front. Others mentioned mysterious British vessels that had spun metal cable into the sea. German officers dismissed these accounts as psychological warfare, fantasies meant to inflate Allied prowess. Still, the evidence refused to vanish. In November 1944, a Luftwaffe reconnaissance flight over northern France photographed massive spools of coiled metal near Rouen. Analysts, unfamiliar with pipeline reels, misidentified them as telecommunication equipment for command networks. When German patrols later uncovered fragments of buried piping near abandoned Allied camps, the tone changed from skepticism to alarm. Within weeks, the Abwehr circulated an extraordinary internal memo describing a possible fuel telegraph system, a network transmitting oil through underground pressure rather than by tanker or truck. The phrase bordered on absurdity, yet it was closer to the truth than they realized. Sabotage teams were dispatched to investigate, but they rarely found their targets. The pipelines ran too deep, too dispersed, and too heavily guarded by engineers and local resistance fighters. A captured German captain near Namur scrawled in his diary, "The Americans conjure fuel from the soil. Our tanks rot for want of a drop." By December, High Command finally accepted what it could not counter. The Allies had achieved logistical invincibility. Pluto and Dumbo had transformed supply from a weakness into a weapon, rendering German strategy obsolete. Against this unseen artery of steel and pressure, no amount of courage or desperation could prevail. Through the summer and autumn of 1944, while the headlines glorified the tank commanders and fighter aces, the true miracle of mobility depended on men and women whose names history seldom recorded. Over 4,000 engineers, welders, sailors, and technicians from the British Petroleum Board, the Royal Engineers, and the U.S. Army Corps of Engineers worked in relentless shifts, binding together the arteries of Pluto and its overland extensions. In blackout factories across southern England, civilians labored beside uniformed specialists, their sparks flaring through the night. Every joint they welded, every valve they tightened, meant one more mile of fuel reaching the front. At Siemens Cable Works in Woolwich, rows of women wound the delicate HAIS pipe onto vast drums, each coil weighing more than 100 tons. Many came from families displaced by bombing, now serving the war not with rifles, but with copper and steel. In Scotland and northern England, the Anglo-Iranian oil company repurposed its refinery staff into pipeline fabricators. They worked in freezing sheds where the smell of oil mixed with sea air, producing flexible steel veins that would soon feed an army. At sea, the U.S. Navy Seabees and merchant crews took over. On ships like the Empire Baffin, they manned the massive conundrum drums, floating giants that unspooled miles of pipe across U-boat-infested waters. Each voyage was a gamble. One strike from a torpedo could sever a month's labor. Yet the crews pressed on, trusting in secrecy and speed more than armor. On land, maintenance teams lived half-buried in concrete pump houses from Cherbourg to Falaise, listening to the constant heartbeat of gauges and compressors. When a section ruptured near Falaise in October 1944, killing 7 men, repairs began before dawn. The system's survival demanded precision bordering on obsession, each joint calibrated for 1/200 pounds per square inch. Every bend measured against terrain and temperature. Generals like Eisenhower and Montgomery later admitted that no victory could have been sustained without these men and women. They were never mentioned in communique, but they built the silent mechanism that kept Europe's liberation alive. As the bitter winter of 1944 approached, their endurance and the pipelines would face its greatest test. December 16, 1944, dawn in the Ardennes. Snow smothered the pine forests of Belgium, and the fog hung low enough to swallow whole battalions. Then came the thunder of engines, German panzer divisions bursting from the mist, hurling themselves against thin American lines. Hitler's Ardennes offensive, the last great gamble of the Reich, had begun. For the Allies, the shock was immediate and devastating. Fuel depots were captured or destroyed, supply roads choked with retreating vehicles. The entire logistical spine of the Western Front seemed on the verge of collapse. Amid the chaos, one question dominated headquarters briefings from Eisenhower's SHAEF to Patton's Third Army. Could the Dumbo pipeline survive? Beneath the frozen soil of France and Belgium, thousands of miles of buried steel carried the fuel that kept Allied armor alive. If the Germans severed those lines, the counterattack would stall before it began. Engineers from the U.S. Army Corps and Royal Engineers raced to reinforce vulnerable segments, rerouting pressure and digging fresh bypasses under shell fire. In the bitter cold, men worked barehanded with wrenches that froze to their skin, guided by the dull pulse of the pumps miles behind them. On December 23rd, artillery fire shattered a section near Liège, halting flow to the northern front. Within 48 hours, welders had patched the rupture and restored delivery. 600,000 gallons per day once again surged forward. That constant stream of fuel allowed Patton's Third Army to pivot north with breathtaking speed, slamming into the German flank and sealing the fate of the offensive. By early January 1945, the Wehrmacht's advance had withered not from lack of will, but from lack of gasoline. Captured reports told of tanks abandoned intact, their crews forced to flee on foot. The contrast was stark. German armor stood frozen in the snow, while Allied convoys rolled forward, sustained by the unseen arteries of Pluto and Dumbo. The Battle of the Bulge ended as proof that in modern war, logistics, not glory, decided victory. As the snow began to melt, the invisible river of fuel turned east again, pressing inexorably toward the Rhine. March 1945. Dawn broke cold and pale over the Rhine River. Its surface glazed with mist and the smell of cordite drifting from the western bank. For months, the river had stood as Germany's last great natural barrier, a liquid fortress dividing the Allies from the heart of the Reich. Yet behind the thunder of artillery and the grinding advance of armor, another kind of offensive was unfolding, one measured not in shells or divisions, but in gallons per day. By now, Operation Dumbo had matured into a continental marvel. From Port-en-Bessin to Antwerp, through Maastricht, Liège, and across northern France, a steel labyrinth of more than 1,200 miles pulsed invisibly beneath the soil. Its pumping stations, disguised as barns, workshops, or ruins, fed an unbroken stream of gasoline that sustained the Allied armies pressing east. The British Petroleum Board and U.S. Army engineers had synchronized their systems into one living network, capable of delivering 1.25 million gallons every 24 hours. What had begun as a desperate experiment in 1942 was now a mechanical juggernaut keeping pace with the fall of an empire. As the U.S. Ninth Army seized the Ludendorff Bridge at Remagen, engineers on the western shore confirmed that fuel from English ports was already powering the 3rd Armored Division's Shermans rumbling across. The feat defied comprehension. Gasoline drawn from refineries near Bristol and Southampton was now burning in engines less than 50 miles from Cologne. German artillery searched in vain for supply convoys, shelling empty roads and ghost depots. The pipelines were buried too deep, their junction valves sealed beneath layers of clay and camouflage. To the Germans, starved of oil and crushed by Allied bombing of their refineries, the sight of enemy tanks refueled endlessly was the final humiliation. A captured officer near Remagen summed up the despair. Their fuel seems as endless as our defeats. The crossing of the Rhine marked more than territorial conquest. It was the triumph of industrial logistics, the moment when war itself became a science of flow and pressure. The steel arteries that had fed Europe's liberation were about to complete their purpose, and soon, their dismantling would begin. From an engineering standpoint, Pluto was nothing short of audacious, a fusion of science, metallurgy, and logistics that turned the English Channel into a controlled laboratory of pressure and flow. Every mile of pipe represented a victory of calculation over chaos. Each undersea line had a 3-inch internal bore, built to withstand pressures exceeding 1,500 pounds per square inch, enough force to rupture most commercial pipelines of the era. Specialized pumps, designed by Dorman, Long and Cowers and Worthington Simpson, maintained the steady heartbeat of the system across hundreds of miles. Their pistons thumped in perfect rhythm, day and night, turning raw petroleum into the bloodstream of liberation. But the brilliance of Pluto lay not only in its strength, but in its adaptability. Engineers soon discovered that temperature shifts between the frigid channel depths and the warmer French soil caused subtle contractions that could choke the flow. Terrain gradients added further complexity. Even a few feet of elevation could alter pressure by thousands of pounds. To compensate, technicians designed automatic relief valves, pressure equalizers, and synchronized pumping intervals, all calibrated through ceaseless observation and improvisation. A single error in timing could rupture a section. A single faulty weld could stall the advance of an entire army. The two principal designs, the HAIS and HAMEL pipes, embodied the innovation that defined wartime Britain. The HAIS line, sheathed in lead and wrapped in steel wire and tarred jute, offered both flexibility and resilience against seabed friction. Dumbo's overland extension used mild steel, welded in 30-foot lengths and buried at least 3 feet underground to protect it from enemy sabotage and frost. Each of its 150 pumping stations drew power from converted Rolls-Royce Merlin aircraft engines, their throbbing echo a mechanical symphony stretching from the Channel to the Rhine. What made Pluto extraordinary was its modularity. its ability to be extended, rerouted, and repaired within hours. It was a living system, responsive to the demands of battle. Post-war German engineers, astonished by its sophistication, confessed that had they understood its scale, they would have dedicated entire air fleets to its destruction. But by then, it was too late. The invisible pipeline had already accomplished the impossible, turning engineering into strategy and pressure into victory. By early 1945, the miracle of PLUTO had evolved beyond machinery. It had become a weapon of faith. Allied troops who had once rationed every gallon in North Africa now moved across Europe with the assurance that fuel would always be waiting. Tank crews joked that their Shermans drank from an invisible hose, a phrase General Patton himself repeated with pride. To the soldiers grinding forward through mud and rubble, this unseen river of gasoline was more than logistics. It was proof that the war was turning irrevocably in their favor. Each refueled convoy, each air sortie that launched without delay, reinforced the sense that Allied industry itself was fighting alongside them. For commanders, the psychological effect was equally profound. Gone was the constant dread of supply paralysis that had haunted earlier campaigns. With PLUTO and Dumbo running beneath their feet, generals could plan offensives on speed and momentum, not fuel availability. It allowed Patton's thrusts to roll uninterrupted, Montgomery's armored columns to maintain pressure, and airfields to keep fighters aloft without pause. The invisible network transformed confidence into doctrine. Momentum itself became a weapon. For the Germans, the effect was catastrophic. Intercepted radio transmissions from late 1944 revealed disbelief verging on despair. How could an enemy burn so much fuel without pause when the Reich's own tanks sat silent for lack of it? Field units resorted to hoarding, siphoning from wrecks and abandoning vehicles to save precious drops. The contrast became emblematic of the wider war, one side powered by scarcity, the other by unbroken flow. Civilians in liberated towns saw endless columns of jeeps, trucks, and half-tracks, unaware that these visible convoys were only the skin of a vast mechanical organism whose lifeblood moved underground. As one American engineer reflected after the war, "The men at the front fought with bullets, but we fought with pressure gauges." By the time Berlin awaited its fate, the psychological war of logistics had already been won. And even as peace approached, PLUTO's buried arteries had one final duty left to perform. May 1945. Germany's cities lay silent beneath drifting smoke, and yet, beneath the soil and seabed, the great arteries of PLUTO and Dumbo still pulsed. Even after the guns had gone quiet, fuel continued to flow, feeding the vehicles of occupation, the generators of field hospitals, and the trucks hauling food into the ruins of Europe. For weeks after VE Day, the invisible network that had sustained liberation now powered recovery. From the pumping stations of southern England to the depots along the Rhine, valves remained open, gauges steady, the heartbeat of war slowly easing into peace. By the summer of 1945, engineers began dismantling what had been the most ambitious logistical system ever built. Over 180 million gallons of fuel had coursed through its veins, enough to power every Allied tank, truck, and aircraft that had fought across Western Europe. Much of the steel was salvaged for reconstruction, repurposed to rebuild the very nations it had helped to free. Yet many lengths of pipe remained buried, too deep or remote to retrieve, sleeping beneath roads and fields that still follow the line of the Allied advance. Captured German engineers, poring over blueprints called PLUTO, a feat beyond wartime imagination. Its creators received no parades, only quiet commendations buried in technical appendices. But their legacy endures wherever the movement of fuel, data, or supplies determines victory. Decades later, rusted coils of HAIS pipe would wash ashore on Normandy's beaches, a ghost of the steel river that had once turned the tide of history. The Germans, who had dismissed the idea of an undersea oil flow, never realized the truth until it was too late. By the time they believed in it, it had already carried the Allies to their doorstep.